will show you how to use the power rule. So how to find derivatives of functions which are powers. For example, x to the power of 12. I will use the power rule because it is a power, and it works like this. I take my power, I put it at the front of everything. So my derivative will be first 12, first the power that I had, then x, and the power changes. You subtract 1 from the power. So I just subtract 1 from 12, it's 11. That's the new power. And that's it. Let me write down the rule for you. So if I have a function which is a power, x to any power, let's say n, the derivative is, I put the power at front of everything, so n, and x is now to the power of n minus 1. I subtract 1 from the power. Let's try another example. Let's say that I have a function which looks like this. X to the 1 over x to the power of 5. Okay. Again, I can use the power rule, but first let's write this function as a power, clearly. If you ever have a flipped expression, 1 over x to the power of 5, you can always change it into x to the power of minus 5. Flipping is negative powers. A flipped expression is a negative power. So just flip it back, but the power will change to minus 5. This is something to remember. And the derivative, use the power rule. What did we do? Minus 5 goes to the front of everything. The power goes, and we have to subtract 1 to create a new power. Minus 5 minus 1 is minus 6. A very common mistake is to write minus 4 there. So we have to keep in mind that we subtract 1. Always subtract 1. Minus 5 minus 1 is minus 6. You have less, right? Then let's try another example. Let's try roots. Why not? I like roots. Why not roots? Roots can also be written as a power. A root is a power which is a fraction. Square root is a power 1 over 2. Cube root would be 1 over 3. Fifth root would be power of 1 over 5. Lovely. And then if I clearly have a power, I use the power rule. Why not? So half goes here, half, and x is to the power of 1 less. Half minus 1 is minus half. Lovely. Let's continue using the same rule. Let's try 2 more examples. One with roots and one with a combo, flipping end roots. Okay, let's try. So now my function will be fifth root x to the power of 3. Okay, first I will write it clearly as a power, so I know how to use my power rule. X is to what power? Well, fifth root is a power which is a fraction, which is over 5, and the cube stays. So fifth root of x cubed is x to the power of 3 over 5. That's the rule, and now let's use the power rule to find the derivative. The derivative is, okay, so I take my power to the front of everything. So 3/5 goes to the front. X is to the power of, subtract 1. 3/5 minus 1 is minus 2/5, I think. There you go. That's your answer. If you have a power, you just put the power to the front of everything and subtract 1 to create the new power. And now, let's try another one. Now, that will be a combo. we'll flip it and there will be a root involved. Okay, so a root is a power of half, right? But it was flipped as well, so I want to unflip it, I need to add a minus. Lovely. Now let's find the derivative. Using the power rule as usual, let's put the power in the front of everything, and x is to the power of minus half minus 1 is minus 3 over 2. And that's it. Let's try something where we also have to add and subtract. You can call it an addition rule and subtraction rule, where expressions are added, you just find, or subtracted, you just find the derivatives separately and add or subtract expressions. Let's try one. Let's say 5x cubed minus 3x squared plus 7x. Okay, took me a while, but that's my example. That's my final decision. Now, let's just use the power rule as usual. So I want to take my power and put it in front of x. So bear in mind that here we had 5 times 3x cubed. So as a result, I will have 5 times 3, which is 15. We have to just multiply a constant by 3 to get the new number. It's multiplication, is my point. It's not addition or anything weird. Then x is to the power of, well, a new power is always minus 1, so 3 minus 1 is 2. There was subtraction involved, so basically you just leave this minus here. And let's take the next one. Now we will have to find the derivative of 3x squared. So again, I use the power rule. 2 goes to the front of everything, so it's 3 times 2, which is 6. And x is to the power of, I subtract 1, 2 minus 1 is 1. Again, there is addition here, so I add. And I have 7x. Well, x without a power is just x to the power of 1. There was nothing here. It's the power of 1. So again, you can use the power rule. 1 goes to the front of everything. 7 times 1 is 7. And I subtract 1. So I get x to the power of 0. X to the power of 0 is just 1. So I don't have to write anything here. This is just 1 times 1. 7 times 1 is 7. So basically my point is, if you see just x, it means that x will disappear, because you will get x to the power of 0, and that's 1. Beautiful. That would be this example. Of course, I don't have to write to the power of 1 here. I can just erase it, and now it looks neat. Let's take a look at the next one. What will we do if you have x minus 3 times x plus 2? Wow. We cannot invent any kind of product rule here. Okay, so it won't be the derivative of x minus 3 times the derivative of x plus 2. It doesn't work like that. It only works with addition and subtraction. Okay, if there is addition, if there is subtraction, I can find the derivatives separately. But if there is multiplication, no. You have to be extra careful. If there is a multiplication, you have to expand. Okay, expand to get an expression with powers and addition and subtraction only. So we'll expand those brackets by multiplying everything by everything. Okay, let's go. X times x is x squared. X times 2 is 2x. Minus 3 times x is minus 3x. And minus 3 times 2 is minus 6. I will also simplify it. I can collect like terms. 2x minus 3x is minus x. Okay, that's how you deal with multiplication. You have to get rid of it. You have to expand. You can't write down that it is the derivative is the derivative of x minus 3 times the derivative of x plus 2. No, let's forget about it. If there is multiplication, if there's a product, you cannot find the derivatives separately and just multiply them. That doesn't work like that. You have to expand and find the derivative of the new expression, of the expression that we got after we multiplied the brackets. This one, x squared minus x minus 6. Okay, so to find the derivative of x squared, again I use the power rule. So put the number in front, the power in front of everything, so it is 2. And x is to the power of, well, 2 minus 1 is 1. As I said in the previous example, minus stays, so it's minus. And now x is to the power of 1, so it goes to the front, it's 1. And we subtract 1 from the power. 1 minus 1 is 0. Well, okay, I can write it for you. It's x to the power of 0, which will basically mean that it will disappear. And again, minus stays as a minus, and we have to find the derivative of 6. Wow, how to do it? Will I use the power rule? I think a lot of people just remember that the derivative of a constant is 0. I would just like to quickly explain why. Okay, because a lot of people can just remember, okay, if I have x, x disappears because x to the power of 0 is anyways 1. So if I have the derivative of x, it's simply 1. Now, if I have a derivative of constant, I would suggest remembering that it is just 0, that constants disappear. But I can show you why. 6 I can write as 6x to the power of 0, right? And x to the power of 0 is 1. And now if you take the power in front, you will have 6 times 0. So that's why it disappears. And so if you have the derivative of 6, the derivative of 6 is 0. The derivative of any constant will be 0, it will just cancel out. So my final answer is 2x to the power of 1, so just 1, minus 1x to the power of 0, so just minus 1, and minus 0, which I don't write. Let's take a look at the last example that I wanted to show you. Now again, we will use the power rule, but we have to be careful. Now we have a fraction. Again, you can't just find the derivative of top over derivative of bottom. I know it's tempting, but that's not how it works. You can find the derivative separately only if it's additional subtraction. If there was multiplication, we had to expand. If there is division, if there is a fraction, if there is a quotient, we will separate it. Okay, so I can separate fractions. Look, here I have 3x cubed over x. X cubed divided by x is x squared. So it will simply be 3x squared. X is x to the power of 1, 3 minus 1 is 2. X cubed divided by x is x squared. Then I have this plus here, so I just copy a plus and take the next one. Now it's x squared over x is x. 2 minus 1 is 1. Okay, x to the power of 1 is x. Then there is a minus, so that's what I copy. And take the next one. It's 2 over x. 2 over x. Which I will write in a different form. I will copy 3x squared plus x minus, as we learned before, if there is a flipped expression, I can change it into a negative power. There is 2, I will leave 2, and it's over x, so it's x to the power of minus 1. There was x to the power of 1, so now there will be x to the power of minus 1 after unflipping. So that's what I do when I have a fraction. I just split it into separate fractions, separate expressions. And now, since I have only addition and subtraction and powers, I'm safe. Now I can use the power rule. Not here. Here. dy dx. And let's go. The last example. Now we can simply use the power rule. I have 3 x to the power of 2. So the power goes to the front. 3 times 2 is 6. X. Subtract 1 from the power. 2 minus 1 is 1. There is a plus, so I copy a plus. X is just x. We already learned that it will mean that it will disappear, okay? So just keep in mind, x is x to the power of 1. 1 goes to the front. And x is to what power? Well, I have to subtract 1. 1 minus 1 is 0. So x to the power of 0, I don't have to bother, it will be nothing. Minus 2, and x is to what power? Well, first of all, I have to take 1 in front of everything, so it will be times minus 1. And x, I have to subtract 1 from the power. Minus 1 is minus 2. Okay, let's tidy it up. So I have 6 x to the power of 1, so just x, plus, there was x to the power of 0, so I just write plus 1. Now minus 2 times minus 1 is plus 2, and x is to the power of minus 2. That's it. So just to sum up, if you want to use the power rule is if the function is x to the power of n, then the derivative is n x to the power of n minus 1. You take your power in front of everything and you subtract 1 to create the new power. I hope this video was helpful for you. If you have any questions, ask in the comment. I will try to help.